Hello, my name is Muhammad Kimi bin Mustafa Kamal. My metric number is DE190067. I'm going to present about the introduction. Control system is a combination of various elements connected as a unit to direct or regulate itself or any other system in order to provide a specific output. There are two types of control system, which is open loop control system and closed loop control system. In open loop control systems, output is not fed back to the input, but closed loop is the other way around. In the open loop system, the applied input or the controlling factor is independent of the system output. In a closed loop system, the applied input or controlling factor depends on the output of the system. The closed loop control systems are also called the automatic control systems. Traffic light control system is one of the example of a closed loop control where they have the sensor at the input. The controller produces an actuating signal which controls the plant. In this combination, the output of the control system is adjusted automatically until we get the desired response. That's all from me. Thank you.
Yes, Assalamualaikum. My name is Muhammad Kiraan bin Chamat. My metric number is CE180079. I'm going to present about the methodology. Okay, the methodology. First one, we sketch a block diagram and copy the plan of the DC motor. Then make the block diagram utilizing by MATLAB software to produce the output. Secondly, use MATLAB software to apply the usage of the regulator. It produces the measure of the output voltage signal. As you can see, this is the figure of the position PID in control system.
Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Safi bin Muhammad Saleh. My student registration number is DE190048. Okay, so today I will begin the presentation for our simulation. Okay, first we have construct the variables in this form of code. Okay, next I will run it. Alright, next I will open the Simulink which we have constructed here. So this is our block diagram for overall of our Simulink system. Next for apa? For the simulation to work, we have to construct our subsystem here, which we have done. In here we have our formula that we have constructed. Okay, I will demonstrate for our P controller first. Okay, first I will select this part. Okay, I have selected P controller over here, and I already applied. And next I will tune. Okay, this might be take a while. Alright, so I'll play. Okay, so this is our graph for our P controller. Next, I will tune the response time second to 5 seconds. So after tuning, our graph will show exactly like this. Next, I will show the parameter. Okay, in the parameter settings, okay, we have identify here the overshoot is less than 10%, which is 8.77%, and then the peak after tune is 0.999, and the block is at 1.09. Okay. Next, I will display for the VM graph here. Alright, this is our VM graph for our P controller. Next, I will move on to X1 graph here over here. Alright, so it should be we have gained our graph exactly like this. Next, for our X graph over here. So the graph that we should path is supposed to look like this. Okay, so next I will present for our PI controller, okay, which here I have selected. I have applied. Next I will tune. Alright. So this is our graph before tuning for our PI controller. Next I will tune the response time to 5 seconds. Okay, next we have this graph over here. Next I will show the parameter. Okay, in the parameter, the overshoot before tuning is 16.7% and after tuning is 23.2%. And the peak before tuning is 1.17 and after tuning is 1.23. Next, we will display the VM graph over here for PI controller. Here I will play. Okay, so this is our graph of VM graph for PI controller. Next, I will show for X1. This is our graph for PI controller for X1 graph. And lastly, X is here. Okay, then that is all from me. I will pass the next presentation to Shafika.
Okay, now we are going to see for PD controller. So we're going to apply and tune. Okay, so this one is our graph after tuning, and now we are going to change our limit time for 5 seconds. Okay, this is after tuning to 5 seconds, and now we are going to look to the parameter. Okay, before tuning become 8.77% and after tuning is 0%. For the peak, the before tuning is 1.09, after tuning is 0.99, and now we're going to look for the VM graph, X graph and X1 graph. For the VM graph, I'm going to run, and this one is for VM graph for PD, and we are going to look to X1 graph. This one is for X1, and lastly for X graph. Okay. This one, okay, we are going to look to the last controller is PID. Apply, and we're going to tune. Okay, so this one is our PID graph before tuning to 5 seconds. So we are going to tune to 5 seconds. Okay, this one is our graph after tuning 5 seconds, and we are going to look to our parameter. So for our parameter, before tuning is 16.7% and after tuning it's become 13.1%. For the peak is 1.17 and after tuning is become 1.13. And now we are going to look to VM graph, X graph and X1 graph for PID. Going to run the graph. Okay, this one is our VM graph for PID. Okay, this one is X1 graph, and lastly for X graph. Okay.
Conclusion and recommendation. Realize in conclusion that the PID controller is the workhorse of modern system of process management. The mode of additive, integral and derivative regulation it serves a specific task. For most control loops, proportional and integral control modes are important, although the derivative are only useful in certain situations.
There are various design of PID control algorithm, and the Mac 20 support both the most common non-interactive algorithm and the parallel algorithm. In order to complete this assignment well, they must be qualified and master this subject for our referral to other students. In order to build it using MATLAB tools, they will need to be certified to use MATLAB. They can't get the answer if they can design it. Other than that, to get more information to ensure they learn about it, they should even refer more video or notes on the internet and YouTube. Lecturer will also provide students with more feedback and ensure that they know how to do this project simply, since we cannot see face to face with our lecturer today. So we use Google Meeting and WhatsApp to inquire and speak to lecturer because we only have an online session.